So this video will go over section 3.4 on naming ionic compound. So now that we know how to write the formulas for ionic compound, we will learn to name them. Let's go through naming cations, positive ions. So the main group metal cations, group 1A, 2A, and 3A, are named for the element from which they are formed. So, for example, sodium, the Na plus ion is called the sodium ion. K plus ion is the potassium ion. Ca2 plus is the calcium ion. Mg2 plus is the magnesium ion. So you just take the name from the periodic table and keep it as it is. When a metal is able to form two different cations, follow the name of the cation by a Roman numeral in parentheses to indicate its charge. So, for example, the variable charge metals are typically the transition metals in the B group of the periodic table. And so iron is a typical example. So iron often is a 2+ ion or a 3+ ion. So to indicate that the compound contains the iron 2+ ion, in the name we will use iron 2. The 2 here is the Roman numeral for 2. It's like 2 capital I. Fe3+ is the iron 3. So the Roman numeral indicates the charge in parentheses. So these are examples of common variable charge metals. So most of them, as I said, are transition metals from the B groups. But there is also bismuth here. Bismuth is a metal from group 5A, and also tin and lead are also metal from group 4A, which are not B groups, but A groups. And so these are also variable charge metals. So tin, for example, is often a 2+ or 4+ ions. So notice how 4 in Roman numeral is capital I and capital V. Capital V means 5. And so capital I before capital V means it's 5 minus 1, and that's 4. And so, for example, bismuth here, bismuth 5+ is bismuth 5. And so 5 in Roman numeral is the capital V. So you can look at these. Now, let's name the anions, the negative ions. Anions are named by replacing the ending of the element name by the suffix "ide". So there's not that many anions made of a single atom. And so these are, so mainly from the halogens, bromine becomes the bromide ion when it's Br-. Chlorine, Cl- is the chloride ion. Fluorine, F- is the fluoride ion. From iodine, I- is the iodide ion. Then there is a nitrogen, N-3 is the nitride ion. Oxygen makes the ion O-2, it's the oxide ion. Phosphorus, P-3 is the phosphide ion. And sulfur, S-2 is the sulfide ion. So make sure you sulfide and phosphide, it's important you recognize these names, oxide and nitride. So all of them are used a lot, and so be familiar with these names. And so now let's name a full ionic compound. And so compound of the main group metals. So first you want to name the cation and then the anion in order that they appear in the formula. You do not specify the charge on the ions. You do not specify how many ions of each type are needed to balance the charge. It's very simple. You take the name of the metal, which comes from the name from the periodic table. For example, Na plus is sodium. If it's bonded with F minus, which is the fluoride ion, then NaF, the compound, is named sodium fluoride. You put them in the same order as they are in the formula. For example, Mg2 plus, that's the magnesium ion. When it's combined with the chloride ion Cl minus, the formula is MgCl2 and the compound is named magnesium chloride. You just take the names of the ions and put them together with the metal first and the metal cations first and the anion second. So let's do a quick learning check here. So select the correct name for each of the following ionic compound. So CaS, we know it's ionic because calcium here is a metal. And so when you name them, you just keep it as calcium from the periodic table. And then S, it's sulfur, but when it's an ion, it's called the sulfide. So the answer is calcium sulfide. K2O, K is potassium, and O is oxygen, but when it's the ion, we call it the oxide ion. So then the name of this compound is, of K2O, is potassium oxide. Now, compound of metals with a variable charge. So as we said, when we have a variable charge metal, we need to specify in Roman numeral the charge of the metal in that compound, because it can be different depending on the kind of ion that the metal is. And so, for example, if you have this formula, Cu2O, so you need to determine the charge of the cation from the anion. So here, copper, Cu, is copper. Copper is a transition element, and so it's a variable charge metal. So we know it can be typically +1 or 2+. Copper is making those two type of ions. So we need to determine what is the ion we have in this formula. Oxygen, O, is a predictable ion, which means that from the position in the periodic table, you can find out the charge of the oxygen ion. And so oxygen is in group 6A. 8 minus 6 means it will form a -2 ion. Oxygen is a non-metal, and remember that non-metals make negative ions. So it's O -2 because it needs 2 more electrons to be like neon. So we know we have oxygen -2 in this formula. And we know the formula is neutral, which means all the negative charges are cancelled by the positive charges. So here we have only one oxygen in the formula, and it carries 2 negative charges. So we have a total of 2 negative charges in the formula. And we need then 2 positive charges to cancel those 2 negative charges. So we know the 2 coppers there must carry 2 positive charges in total, because we have 2 atoms of copper, so they will share the charges, and then the copper will be copper plus with 1 positive charge, because there are 2 coppers, then those two Cu plus will make two positive charges and cancel the two negative charges from the oxygen. So the name is then copper 1 in a Roman numeral. And then we name the anion, and oxygen, when it's the ion, it's called the oxide ion. You change the ending to "ide." And so that means we have copper 1 oxide. So let's do a learning check here. And so you want to name each of the following ionic compound. So you're given the formulas, and from the formulas, find out the name. So please do this on your own before you watch the answers. So Li2S. Li is lithium, group 1A, and S is the sulfur, the non-metal from group 6A. So lithium is from group 1A. It's a predictable ion, so we know it's always Li+. Because it's a predictable ion, we will not need the Roman numeral. So it will be called lithium. And then the sulfur ion is called the sulfide, right? We change the ending to "ide." So this will be the lithium sulfide compound. Compound B is SnCl2. So Sn, if you find it in the form in the periodic table, it's tin. Tin is in group 4A. The metals from group 4A are not predictable ions. They can be different kind of ions. So we have a variable charge metal here, and we will need to find its charge in this compound by using the anion, the charge on the anions, and then because the formula must be neutral, then you can find out the charge on the tin, on the cation. So Cl is chlorine, atomic number 17 in group 7A. Chlorine, there is 2 of them, and chlorine, being an halogen with 7 valence electrons, likes to gain 1 electron to have an octet of valence electrons. So it's going to make a Cl minus anion. So we have 2 Cl minus anions, which means 2 negative charges in total that must be cancelled by positive charges on the tin. There is only 1 tin, so we need 2 positive charges on that tin. And so tin will be Sn2+. And so because it's tin 2+, then the name will be tin 2, and then chlorine becomes the chloride ion, and so it's tin 2 chloride. Right? When you have a variable charge metal like that, you need to use the anion to retrieve the charge on the metal in that formula, using the fact that the formula is neutral. The total number of positive charges must equal the total number of negative charges. Let's do Al2O3. Al is aluminum, O is oxygen. So aluminum is in group 3A. It's a metal that is giving a predictable ion because it's in group 3A. Predictable ions are found in group 1A, 2A, and 3A. The group number is the charge on the ion. So it's aluminum 3+. We know it's always aluminum 3+. And here oxygen gives the oxide ion. So you simply name by giving the name of aluminum, oxide. There is no need for a Roman numeral because aluminum is a predictable ion. ZNO. ZNO, sorry. Zn is zinc. That's a variable charge metal. It's not a variable charge metal actually. So if we go back to that slide 13, where we had the metals with variable charge. So here, most of the transition metals, so metals in B groups, are variable charge metals. But there are two exceptions. Zinc is an exception and silver is an exception. Zinc is always zinc 2+, and silver is always silver Ag+, 1 positive charge on silver and 2 positive charges on zinc. So because zinc and silver are exceptions among the transition metals, they are known, and we do not need to use the Roman numeral for these two. So zinc is 2+ because it's an exception. And so we don't need to use the Roman numeral. And O is the oxygen, and as an ion, it's the oxide. So it's going to be called zinc oxide. The last one, CrBr2. Cr is chromium. That's a transition metal in the B groups near the middle of the periodic table. And that's an exception. It can vary in the type of ion it makes. So we will need to use the formula CrBr2 to find out what is the charge on chromium in this compound. Br is bromine, and bromine is in group 7A. It's an halogen, and it's a predictable ion. The halogens, having 7 valence electrons, like to gain 1 electron to have 8 around them. And so bromine becomes the bromide ion with 1 negative charge. We have 2 bromine or 2 bromide ion in this formula. So 2 bromide with 1 negative charge each means we have a total of 2 negative charges in the formula. So 2 negative charges need to be cancelled by the positive charges that chromium is carrying, and there is only 1 chromium. So that chromium needs to carry 2 positive charges to cancel the 2 negative charges from the 2 bromide. So it's going to be Cr2+. And so now we know it's Cr2+, so the name will be chromium 2. And then bromine is called bromide. So it's going to be chromium 2 bromide. So we also need to be able to do the reverse process, which means be able to write a formula from a name. And let's go through an example to see how we do this. Write the formula for tin 4 oxide. Identify the cation and the anion. That's the first step. So the name is always telling you the cation first and then the anion. The cation is tin 4. Tin has for symbol Sn. And the Roman numeral here tells you that it's a 4+. So it's tin 4+. And then the oxide is the oxygen ion, and oxygen being in group 6A, 8 minus 6 is 2. Oxygen likes to gain 2 electrons to have an octet around it. So it likes to become the oxygen -2 ion. And so that's what we did. We just determined the charge on the cation and the anion. So we have SN4 plus and O -2. Now we keep the metal, the positive ion first, and then the anion second. And we will do the crisscross trick and to balance the charges. So if you do the crisscross trick, you get SN2O4 because the 4 from the charge of tin becomes the subscript for oxygen, and the 2 from the charge of the oxide ion becomes the subscript for tin, SN2O4. However, you need to remember that the formulas must be the smallest ratio of whole numbers that you can have. And 2 and 4 are multiples. If you divide 2 and 4 by 2, you get 1 and 2. So this can be simplified as SnO2. And that's it. The formula for this compound will be SnO2. And we can check that the charges are balanced by looking that we have 1 tin, and tin is 4 plus. So we have 4 positive charges in this formula. And 2 oxide ion, and each oxide is 2 negative charges. So 2 times 2 negative charges, it's 4 negative charges in total. So 4 positive charges cancel 4 negative charges. And so this formula is neutral. And so we know it's correct. Let's do a learning check and write the formula of the following ionic compound. So here you have names, and you want to find the formula for those compound names. Again, try on your own before you watch the answer. So lead 4 sulfide. Lead has for symbol Pb. So we know from the Roman numeral that in this compound it's Pb4 plus. Pb is a variable charge metal from group 4A. Sulfide indicates that it's the ion from sulfur. Sulfur, being in group 6A, likes to gain 2 electrons to have 8 valence electrons around it. And so it's the S-2 ion. So you have Pb4 plus and S-2. Now you can do the crisscross trick where the 2 from the 2 minus of the sulfide ion become the subscript for Pb. And then the 4 from the Pb4 plus becomes the subscript for sulfur. And so it would be Pb2S4. But the subscript 2 and 4 can be simplified by dividing them by 2. And so 2 and 4 when divided by 2 makes 1 and 2. So the formula is PbS2. You simplify the 2 into a 1 and the 4 into a 2. And we can check that this formula is neutral by looking at Pb. Pb, we have one Pb and it's 4 plus. And we have 2 sulfide, and each sulfide has 2 negative charges. So 2 times 2 negative charges, it's 4 negative charges in total. So 4 pluses from Pb and 4 negative charges from the sulfide, the 2 sulfides, they cancel out, and it's a neutral formula. Let's do copper 1 phosphide. So copper has for symbol Cu. Copper 1 means it's a 1 positive charge, so it's Cu plus. Phosphide. Phosphide comes from phosphorus. Phosphorus is in group 5A. So you do 8 minus 5 and it's 3. And so phosphorus, when it becomes an ion, likes to gain 3 electrons and become the phosphide ion P negative 3. So we have Cu plus and P negative 3. Writing them in order with the positive ion first and the negative ion. If you do the crisscross trick now, the 3 from the 3 negative charges of phosphide become the subscript for copper, and the 1 from the positive charge of copper becomes the subscript for P. And so it becomes C3P. C3P is a neutral formula because if you check the charges, so the phosphide ion carries 3 negative charges, and the copper, there's 3 coppers and they each have 1 positive charge. So 3 positive charges from the coppers cancel the 3 negative charges on the phosphide, and that's neutral formula. Let's do titanium 4 oxide. Titanium has for symbol Ti, and so we have Ti4 because the Roman numeral tells us it's a 4 plus. Oxide is the oxygen ion when it gains 2 electrons, because from group 6A plus 2 electrons, that's 8, and it's O negative 2. So we have Ti4 and O negative 2. Keeping them in this order, do the crisscross trick. The 2 from the negative charges of oxygen becomes a subscript for Ti, and the 4 from the positive charges on titanium becomes the subscript for oxygen. And so it would be Ti2O4. 2 and 4 are multiples of 2 and can be simplified by 1 and 2. And so the final formula is TiO2. And we can see that it's a neutral formula because Ti carries 4 positive charges, and the 2 oxide ions, so 2 times 2 negative charges per oxide, that's 4 negative charges. And so the 4 positive charges are cancelled by 4 negative charges, and it's a neutral formula. So section 3.5 on physical properties of ionic compound. Ionic compound at room temperature are crystalline solids with very high melting point and boiling point. So they are solid and they form regular crystals. And so it's very difficult to melt them, and it would be even more difficult to bring them into a gas phase. When ionic compounds dissolve in water, and a lot of them are soluble in water, but not all of them, they will separate into their cations and anions, right? They will dissociate into the ions that they are made of. And so because ions are, charged particles, so they can carry the electricity. And so having ions in solution will increase the conductivity of the solution. So ionic compound, when they are soluble in water, they make solutions that can conduct electricity.